Welcome back to another Catapult training. This is John C. Bland II, and received some questions about utilizing AWS Fargate, what it is, how we can use it, those sort of things. So this is going to start a series of videos where we go into Fargate and we pull it apart, kind of look at it and see how we can best utilize it. This does assume that you have background with Docker. We're not going to cover all the ins and outs of Docker. We'll kind of use Docker, skip over some of the things unexplained, but the idea is to kind of understand Fargate. So what is Fargate? Fargate is basically serverless compute for containers. Okay, there are some servers somewhere, right? Like somewhere there's a server. It just means that you don't have to manage the infrastructure. Just like any serverless platform, the compute is all you need to worry about, not necessarily the system that it's running on and the updates to the system and da-da-da-da-da. More first world problems. It also helps with right sizing, where right sizing is the ability to perfectly choose the amount of compute that you need and not anymore. I'm pretty sure you've had the case where you started an EC2 instance and it was maybe an M5 large, but really you needed a T2 micro, right? This is very important whenever you're trying to control your budget and your bill. So Fargate essentially works like this. So without Fargate, you build the container, you deploy as EC2, provision and manage the compute and memory resources. Then you have to separate your applications in either separate VMs or different ways like that. And then you have to manage your application and you have to manage the VM. So you need to make sure security patches are provided, the latest and greatest XYZ are there, your file size, or your drive storage, those sort of things you have to make sure are there. Of course, you could use EFS and things of that sort. Then you're also paying for not just the compute that you're using, but you're also paying for the EC2 instance itself. And of course, for things that aren't meant to run all the time, it then becomes a bit of a problem of maintaining those costs, because then you have to stop the EC2 instance and then you have to start the EC2 instance and then you got to stop it, then you got to start it, and do that on and off, making sure that it starts up and bootstraps properly and all those sort of things. With Fargate, it's a lot simpler. You have your container image, you build it or use one that's there, you define the memory you want, you run it, and that's it. You only pay for the compute. So let's take a look at how we can actually do this. So we're going to utilize the WordPress image to start with. Just going to play around with it. So if you have any experience with Kubernetes, Fargate is going to be similar, yet it will still be different. The similar concept applies when it comes to clustering. So we have a cluster. We're going to choose how we want to deploy this. In this case, we're going to use Fargate. You can use EC2, just like EKS, where you can say I have an EKS instance, or EKS is for Kubernetes. I have EKS with node groups and I have my EC2 servers, and you're back to managing servers at that point. So in this case, this is going to be Fargate, networking only, VPC if we want to. So we're going to go ahead and name this one. Let's call it Fargate Intro. And we can create a new VPC if we would like for this cluster. Add our tags, utilize some container insights. All right, so here's our cluster. So let's go take a look at it. We're not being charged for anything because it's essentially nothing more than a placeholder for our services and our task. All right, our cluster is ready. So before we start a service, let's create a task definition. And we're going to choose Fargate. Let's call this one WordPress. The task role allows you to access other AWS services. If you need to access SSM secrets, IAM, VPCs, or anything else, you can have a task role that allows you to assume that role and access certain resources. The execution role allows you to push the logs to Amazon CloudWatch. We're in VPC mode, and this is our compute. So we can choose how much compute. Now, these things have to similarly match up, right? So this does need to kind of follow the way EC2 instances are kind of configured. So in this case, I would need to bump up the gigabytes in order to get the system configured effectively. But we don't need that much. So we're just going to go with a simple small system at this point. Now we need to define our container. I'm going to call it WP. The image is called WordPress. So I'm just going to say, get me WordPress, and I want to use, let's just say PHP 7.2. By default, it's going to use the images from Docker Hub. We don't have any private authentication. It's a public image. We can provide limits, so that way we can run multiple containers, and we can say one container can consume, let's say in this case, 128 megabytes, and then another one can maybe consume the other 300 or so megabytes. In this case, we don't need to do anything. It's just one container. We can also open up ports if we need to. We can control health checks. We can set environment specifics, like controlling the entry point or the command that's being used, working directory, environment variables, as well as using the systems manager parameter store in order to provide some secrets, so they're not in here because everything in here is plain text. We have container timeouts. We can customize some network settings here. We have storage, so we can say the file system is read-only, meaning we cannot write to the file system at all. We can also mount volumes onto the container, and we can configure logging. So by default, these are the available Fargate logs. So you can log directly to CloudWatch if you would like, or no logging. We're going to start off with no logging. And then we can set resource limits and add some Docker labels. We're not going to look at the rest of these settings right now. They're a little bit more of an advanced tutorial, but these are other options that you can place on the task definition. Great. So we created our task definition. We have an instance version of this task definition called 1. It's nothing more than JSON. Okay, so let's go ahead and run this task definition. To run it, we need a service. Well, we didn't create one previously, so let's go ahead and do one now. We're going to launch it as Fargate. The platform version, this refers to the actual Fargate platform version. What cluster are we going to create it into? And let's call this service WordPress. And now this is the great part here. If you were managing your EC2 instances, not in terms of ECS, but just manually, you would have to start 5 different EC2 servers to run 5 different instances. With Fargate, all we have to do is say we want to run 5 of them, and it'll start 5. But we're not. We're going to start with 1. The minimum healthy percentage allows us to be able to say we always need 100% healthy, meaning we need at least one of these things running. So if something is killed off for whatever reason, then it'll automatically start another one. Maximum percent, this is basically the same thing, but it just how many can be running at once. Okay. Rolling update means when we have one version that is running and we start a second version, the first one is not going to stop until the second one is healthy. That way we have 100% uptime. Blue-green is a completely different topic, but it allows you to have 2 instances of the exact same service running, and then you can communicate with them separately. We'll do another video on that later. All right, so we can choose which cluster VPC we want to go into, different subnets. I'm just picking all of them. Why not? We can also create a security group. So in this case, I'm just going to create one here, and we really only need port 80 open, and we want it to be available from anywhere. So we'll save that. We're not going to tie in a load balancer, but load balancers are going to come in a future video. Service discovery is related to app mesh. We're not going to do any service discovery right now. And then we can also configure our auto scaling policy. We're not going to do this, but auto scaling basically allows us to say we want to make sure our containers are healthy at all times, and if they start to get overloaded, we can start up more instances. So in this case, we can either choose CPU or memory. If we notice that our application memory tends to spike when our load increases, we can say whenever our memory gets up to 50%, we can deploy a new task instance, which will give us an opportunity to spread load our service. All right, basics are set. Let's go ahead and create this service. Okay, great. Everything is created. So if we hit view service, it's now provisioning an instance of our task definition. So this is our first version. The task is starting up right now. We have a public IP address here, so it's not available just yet. So what's happening now is Fargate is actually provisioning the resources for us to utilize it. It's placing it in a server somewhere, and it's allowing us to be able to utilize that server. Then from there, it does a typical Docker run essentially and starts up our container. Great, it's running. So now let's check it out. That's it. We're running. I would expect to see some logs here, but we actually didn't use the logs. So how do we actually make changes and adjust this? So let's take a look at another deployment. Let's create a new revision. Everything is going to stay the same, except inside of this container, I'm going to scroll down to the logs, and we're going to say auto configure logs. This is going to basically give us these settings. Now, you can choose, if you would like, to control these values. We're going to go with the defaults. Let's say update, and let's say create. Great, we have a version 2. So right here, we can say update service. Another way to do this, if we go back to our cluster, here's our service. It shows us that version 1 is running. We can go here to update, and it'll get us to the same place. Now this shows us here version 2 is the current version. It's the latest. We're just going to select that revision, and we're going to skip. Everything stays the same, and we say update. So here you see it says we have a deployment ID. The desired count is 1, pending 0, running 0. Also gives us the time. This is the current active one, and that's the last one that we did with the running count. So you can see as we refresh, it's going to adjust the pending, and eventually it's going to be running. If we come back to our task list here, there's our task list showing we're running 1 and 1 is provisioning. You can see I'm refreshing, everything's good to go. That last instance is still there. We now have a logs tab. This is something we didn't have before. So if we come back to the new instance, we can view the logs for this specific task. Okay, great, it's running. Let's go back and take a look at our service. We still have 2 tasks running. This one is still working. Let's take a look at version 2. Let's get that IP address open. Great, there's our version 2. You can tell different IP address. Our version 2 is good to go. If we go look at logs, see how useful that is? Now we actually have logs, and we can see what was happening when everything was starting up. Version 1 is now gone. If we look back at our deployments, boom, there you go. Our primary deployment has a running count of 1. So this is the original one. Now we're spinning. So it's no longer serving on that instance. Now you may say, well, that kind of is unuseful. Our IP addresses are changing every now and then. Well, that's what a load balancer is for. We're not going to look at that in this tutorial, but we will get to the load balancers later. Our version 2 is still up and running. Everything's great. So what happens if this task ends up crashing? Well, let's simulate that. Let's just hard stop it. Service is gone. At this point, our application is down. We have no resources. All the tasks are stopped. So what do we do to recover from this? Well, the short answer is just wait. There you go. Automatically, we didn't have to do anything. It started back up. Now, of course, there is some lag time there. Once the last one finished, there was some orchestration that had to happen for a new one to start up. Right here in the service, we can look at logs, and these will be logs of all running containers. You can look at the logs of the stop containers as well. So if something happened and you wanted to see why it actually stopped, you can see here, that was the reason why it stopped. All right, our new instance is running. Let's take a look at it. Pull up our IP address. We're good to go. So if this was load balanced, it would have automatically shown up in the load balancer as healthy. Everything would have been good to go. We would have had minimal downtime. No one would have had to wake up in the middle of the night. Okay, so what about if you actually wanted to stop everything and you don't want any instances running? Well, that's easy. Set our number of tasks to 0, minimum healthy to 0 as well. Skip the review, update service. So now our desired count is 0 when we stop this instance. It won't start back up. Okay, so that's a simple example. Let's take a look at how we can customize our Docker image by providing some environment variables. So we're going to go through the same steps. In this case, let's call this simple web app colors. I'm going to keep all of these the same. And we're going to add a container. This image name is a little different. So this image is simple. Docker run, define a port. It runs on port 5000. You supply an app color as an environment variable, and that's the name. We have our Docker image named latest. And we're going to skip down here to environment variables and provide the environment variable app color, and we're going to start off with the color orange. Let's give it a little bit of compute here, and let's create it. And while we're in here, we're going to go ahead and create one, and we're going to just adjust this value to blue. So now we'll have two task definitions, revision 1 and revision 2. There we go. So if we come back to our Fargate intro cluster, let's create a new service. We're going to base it on the task definition simple web colors. Let's start off with revision 1. Service name, let's call it colors. Number of tasks, we want 1. Let's place this in a VPC. We'll just choose one subnet. Now this is important for us to be able to expose the port that's needed. So we need to allow port 5000 from anywhere. And we can delete 80, it's not needed. We'll turn off app mesh, no auto scaling, and there's our same basic service like we did with WordPress. The deployment has happened, it's provisioning our resource. Here's our instance. We'll see in a second, it'll actually give us our IP address. All right, our instance is now running. If we refresh our logs, there we go. And now we can take a look at our instance. Sweet, it's orange. So now let's take a look at our colors. And let's just do the same thing and update it to version 2. So from an automation standpoint, you can update these task definitions as many times as you want. The reason I wanted to show this is what I wanted to do was come back to simple web colors and show that we can actually deprovision. So we can say we want to get rid of version 1. We don't want version 1 to be utilized anymore. And that's okay. The number and the version on this service doesn't really matter. It's not something that you're going to keep track of. You're not going to remember. Now we see that version 1 is inactive. If we expand this a little bit, you can see that's the version 1. Version 2 is starting up. And because we don't have a load balancer, it's going to give us a new IP address. But we'll see that version 2 start up. And if we expand this, we can see our color on here is blue. And this is also why you do not want to put secrets inside of your task definition, because they will be exposed to anybody that can view this, and pretty much anybody with access to the account that needs to view Fargate resources should be able to view this view. All right, our service has started our task. If we come over here and just adjust our IP address, now we have blue. So if we look back at colors, our service, eventually it is going to kill off this first version. It is still there for now, but it will go away automatically. So that's a quick tutorial to showcase how to run containers on AWS Fargate. There are so many other layers that we can actually go into: load balancers, app mesh, blue-green deployments, utilizing a code pipeline. There's so many other areas to go into that we can spend a long time on this. If there's a certain area that you would like to see, let us know in the comments. We'll do our best to get a training video out for that. But for now, happy coding.